tonight?
Good, how are you?
Good. What are you doing wanting tutoring on Friday night? Nobody wants tutoring on Friday night.
Yeah, I know.
Huh. I guess if you got a busy schedule, you got to fit it in wherever you can, huh?
Yeah.
Okay. What are we working on tonight?
So earlier in the week, we started working on converting quadratics to the standard form and graphing them.
Okay. You have some problems we can do?
Yeah, I have a few. So this one is just converting it to the standard form, then graphing it. It's x squared minus 8x plus 16.
Plus 16, like that?
Yeah.
Well, that is standard form. Unless they want you to convert it to the vertex form. They want you to convert it to vertex?
Yes. Is that a times x minus h squared plus k?
That's the vertex format. There's actually 3 different kinds of formats. Let's talk about them. Vertex,
Okay.
and I've heard this one called standard also. And I thought I was mistaken the first time I heard it.
Yeah, that's what my teacher calls it.
There's vertex format. Here's x-intercept format. Where P and Q are the x-intercepts. And standard format is what is used for the quadratic formula. So to me, that's the 3 different formats. And like I said, I have heard people call the vertex format the standard format before. So, okay, so I want you to convert it to this vertex format?
Yeah.
Okay, that almost always involves completing the square. Okay, so let's complete the square here. What's our first step?
Move the 16 away.
Yep. Well said. Okay, now what?
Then don't you half the x coefficient then square it?
So and then add it, always add. Because
Yeah.
even if it's a negative number, by the time you square it, it becomes positive. So.
So it's going to be 16.
Okay, and the moment I wrote that 16 in there, I changed everything, so I have to do something to counterbalance it.
So you have to take away 16 from the outside then?
Like that, on the same side of the equation.
Yeah.
So now how can I write this?
Then that's usually just a perfect square, right? So it's probably just x minus
Always,
squared.
it's always a perfect square. That's the whole point. Yeah, that's the whole reason we complete the square is to make that into a perfect square.
Okay.
Minus 0. So, what is your vertex?
Wouldn't my vertex be 4, 0?
4 comma 0, right.
Yeah.
Okay. And then, of course, graphing it helps if we have a vertex. So there's our vertex. That's not completely enough to graph it, but it's enough to show us quite a bit.
And then my teacher also wants the, like, where the 0.11 goes to. So wouldn't that, since there's no, like, stretching, wouldn't it just go to 5, 1?
I'm sorry, I didn't quite get where the 0.11 is?
Yeah, like where it changes to, I guess.
Well, this is a standard y equal, I'm still a little confused as to what you're asking, but if we plotted y equal x squared, it would be right here.
Yeah.
So
Anyone
this
like
function that we plotted is y equal x squared translated 4 units to the right,
mhm. So you would just
based on that.
the 1, 1.
Yeah, it's always x minus h when we're talking translations, and a positive h is translated to the right. And in this case, we have a positive h. H is positive 4.
Yeah.
Okay. Now let's put it in, what are your two formats he wants it in, or do he just want you to graph it?
He just wants me to graph it.
And in order to graph it, he wants what? 3 points?
Just 2.
Okay. Since we don't have any x-intercepts, normally we would have 2 x-intercepts. But in this case we don't, because this actually factors, and it's x minus 4 times x minus 4, so we only have 1 x-intercept, and that's at 4. So what other point would be a good point to graph? Because we don't have, usually x-intercepts and the vertex will give you everything that defines that parabola. In this case, we need 1 more point.
Probably just the point 1, 1. Or,
how about the y-intercept? To me, the y-intercept is the easiest thing to come up with, because the y-intercept is where x is equal to 0, so it's real easy to look at this and know that it is at 16. And if I know that point, and I know this is the vertex based on symmetry, I know that this point is also on it. So now 3 points make a parabola, and I'm done. Okay? I had a student doing this stuff last night. If you run out of problems, let me know. I've got some really good ones and some good exercises to work on this. But go ahead. I'd rather work on your specific exercises.
Yeah, I think there's one I had trouble with.
Okay.
Well, here it is. You just do the same thing, and it's 1/4 x squared minus 2x minus 12.
Okay. It's a little harder to complete the square when you have a coefficient in front of the x squared. It's a lot harder, actually, because most people make a mistake that, what's the first thing I want to do? I'm going to separate the x squared and the 2x term from the minus 12, but then what's the second thing I'm going to do?
Pull out a 1/4, so it's just the...
Yeah, because you cannot complete the square unless the coefficient on x squared is 1. So I factor out a 1/4, leaving x squared, what does this become? Minus 8?
8, yeah.
X minus 36? No, 48. Right, so now I haven't changed anything. Excuse me, let me go back a step. I'm only factoring the 1/4 out of the terms that have x in them. This minus 12 stays over there.
Yeah.
In other words, this is the same as that. Okay? So now what's the next step?
Just have the coefficient squared.
So this is plus 16. So what did I do to the right side of the equation the moment I wrote 16 in there?
You subtracted whatever 16 times 4 is.
I added 16 times 1/4. So I added 4. So I have to subtract 4. In other words, whatever you have to do to balance out these equations, whether it's on the same side or the other side, you have to make sure you multiply this number by this thing that you factored out. Because when I write 16 in there, I'm not adding 4 to the right side of the equation. I am adding 16 divided by 4, or times 1/4. Okay?
Mm-hmm.
So now, how's this inside go?
X minus 4 squared.
Right. Now we have it in standard format. So the vertex is what?
4, negative 16.
Okay. And in order to get another point after the vertex, it would be nice if we could get the x-intercepts.
Yeah.
That's usually what teachers want, is the vertex and the x-intercepts. So before we go to graph it, let's solve for the x-intercepts. How do we do that?
Just set the equation equal to 0.
Yes. Sorry, I was thinking ahead. So we have 0 equals, and I guess we might as well go back to our first equation. There's no advantage in finding the x-intercepts having it in vertex format. In fact, it's probably a little bit of a disadvantage. It's the first thing I'm going to do here.
Take out a 1/4, maybe?
How about I multiply both sides of the equation by 4?
Yeah. That would be good.
Okay? Because it still leaves 0 on the left. But it makes the whole thing easier to factor. Now, factor that. What's the next step in factoring? Let's go through the steps in factoring.
Isn't it just 12 and 4? Negative 12 and positive 4.
It is. Are you good with that? Or do you want me to go through it? All right.
It just took me time to find the multiples.
Okay. That's fine. If you're good with it, we certainly don't need to go over it. Okay. So x equal 12 is one intercept. X equal minus 4 is another. I've got a vertex at, what was that? 4 minus 16. Now, piece of cake to graph. 4 minus 16, let's call that point. X-intercepts of minus 4 and plus 12. There's our 3 points. Easy to graph. Okay. Got another one?
I had problems from a different, concept, but could we go over some of the problems that you have?
Yeah, let me pull up this thing that I just put into my folder here. Let's see. This was actually from an Algebra 2 honors student.
Yeah, I did a lot of this last year also.
Yeah, but these are kind of difficult problems, and let's see if I can find them. Hold on a second. Let me view this in list. I don't have dates on any of these. I guess not. View it back as large icons. Let's see if this is. I had some good graph problems. This, you can tell this isn't bad. Find the vertex, find the domain, find the range, find the zeros. This is exactly what you're doing.
Yeah.
I also had some good ones that had nice graphs like this. This is what I was looking for. If the discriminant is a perfect square and the coefficients are integers, what must be true about the roots?
The roots?
Yeah, in other words, there's a technique for analyzing a quadratic to see whether you're going to get complex solutions or real solutions and how many, or irrational solutions. In other words, when we can factor a quadratic and come up with integer factors, we know we have real solutions and they are rational.
Mm-hmm.
If we can't factor a quadratic and we have to plug it into the quadratic formula, and if the discriminant is positive, we know we're going to get real solutions, but they're going to be irrational. They're going to be solutions that look like this.
Yeah.
If the discriminant, which is everything that's inside the radical, is negative, then we're going to get precisely two complex solutions, imaginary.
Yeah.
So, in other words, this problem, it would be both 2 and 3. I'm sorry. It's 2. Roots are rational, and roots are real, 1 and 2.
Mm-hmm.
Okay. What if the discriminant is negative? What must be true about the roots?
They're irrational?
They're imaginary.
Okay.
Remember, here's what we're talking about when we're talking about that's real, that's irrational, that's imaginary.
Okay.
So when we're taking the discriminant, the b squared minus 4ac, if that is a perfect square, then we will have an integer answer. If it isn't a perfect square, we will have an irrational answer. And if it's negative, we will have a complex solution.
Okay.
This is kind of interesting. Which of these graphs is x minus 5 squared minus 4?
10.
10 has an x 5 and minus 4, yes. Yeah, all the other ones that have that are opening down, so that's the only one. How about B? Which one is x minus 4 times x plus 5?
7? No, wait.
First of all, what format is that in, B? That's not in vertex format. That's in
Factored?
x-intercept format, which is the same as x-intercept. In other words, we know immediately the x-intercepts are 4 and negative 5.
Mm-hmm.
Well,
so it's
and it's got to open up. So where is 4 and negative 5? 13.
Mm-hmm.
It's the only one. It goes through 4 and negative 5. How about this one? With a minus sign in front of it. So those x-intercepts are +5 and -4.
Is it?
It's got to open down also because that negative sign in front has to be down.
Oh, it's 11.
Okay. And number D, 2 times x plus 4 times x minus 5. And then the next one is just x plus 4 times x minus 5. So there's two very similar looking ones here that vary only by their width. So we need, let's see, we need x-intercepts of +5 and -4. Here's one. Now here's another one. So 5 and 12. Am I reading that right? That's 5 and -4. That's 5 and -4. So one of these is D and one of them is E.
But it's going to be a lot, or it's going to be skinnier and taller because of the 2. So it's,
yes, skinnier, for sure. They're all equally tall if you imagine. I mean, these go to infinity. So, but definitely skinnier. And this one appears to be skinnier than this one. Not by 2, though. Really? See, that goes through, yeah, I guess it would. It's twice as deep. So, yeah, that makes sense.
Well, plus the, like the numbers on the graph change.
In fact, the vertex is twice. This one's at 20, it looks like, and this one's at 40. Okay, so let's look at this one here. X minus 4 squared minus 5. What's the vertex on this one?
4, -5.
Okay, where can we find that? +4, -5 on the vertex.
And 7.
I think 9. Remember, we're looking at the vertex. It's easy to get these confused. This is the vertex on 9, which is at +4 minus 5. We're not looking at the x-intercepts. Okay. How about this one with the -2/3? That tells you it opens down. And in fact, this one and this one are going to be the same, except one of them is going to be skinny, one of them is going to be fat. And we have a vertex at 5 minus 4. Well, there's one vertex at 5 minus 4. And there's another vertex at 5 minus 4. And those are the only two vertexes at 5 minus 4. So which one is this one and which one is this one?
The -2/3 is going to be 6.
Correct.
And the other one is going to be 8.
Yep. Yeah, the higher the absolute value of that number, the skinnier it is. And finally this one, x squared, which is in what I would call standard format, x squared plus x minus 30. What do you need to do to that?
Should you factor it?
What's it factor to?
Plus 6x minus 5.
So our x-intercepts are -6 plus 5.
Yeah.
-6 plus 5. That looks like 7. Okay. Let me close that one out. I have one here that's got a really hard couple of problems. Yeah, these are good problems here, where they give you points and make you come up with the equations. Are you doing anything like that in your class?
Not yet.
You want to do this, or
Yeah, sounds good.
do you want to give me some problems, which could be better, but this is fairly instructive. So first of all, they want us to tell them whether we're going to use vertex or intercept form. Hold on, let me reposition my whiteboard here. Excuse me. Every now and then the cursor disappears so you can't see it if it's in the whiteboard. It's very troublesome. You don't know how to monitor. Okay, so based on this, can we come up with an equation? First of all, we're going to put it into intercept or vertex format.
Probably intercept.
Yeah, each one of these, they're going to show us some dots. And we're supposed to use those points to figure out how to put it in. So what's the general format of this going to be in x-intercept format?
It's going to be like, what is the equation going to be?
Well, the general equation is this. So let's fill in for P and Q.
So
we don't know yet. We don't know A yet. P is 0.
Yeah.
Q is 7. So now we can use the other point that they have given us right here to solve for A. And that other point looks like it is 1 minus 12. So if 1 minus 12 is on the curve, then it must satisfy this equation.
Yeah.
So how do I solve for A?
You plug in the x and y of the point for the exit.
Okay, so y is minus 12. X is 1, which makes this minus 6. So solving this for A, I get A equals 2. Now I can go back and write the specific equation for this parabola. I don't need that. I don't need to put minus 0. And then you can either leave it like that or put it in standard form if you wish. Standard form, well, what I call standard form, which is ax squared plus bx plus c. And in fact, the top of this thing even says, look, it's got vertex form is this, intercept form is this, and standard form is this.
Okay.
So there's 3 different forms. About 15. Which form should we use to try to write this equation?
Probably vertex form.
Yeah, notice that one of the points they give us is this. And if we try to see what the x-intercepts are, they're not whole numbers. They don't go through the intercept values. So start me off.
Y equals A times x minus h squared plus k.
Okay. What's my h and k in this case?
H will be minus 4. And then k will be minus 10.
Okay. And then I have my choice of points that I can use to solve for A, but every one of these is going to be the same. You get this far, and then you plug in the third point that they give you to solve for A. And I could use this point over here, but let's use the one that they actually put a label on.
Yeah.
So what's the next line?
It's going to be 10 equals a times 8 minus 4 minus 10. Or minus 4 squared.
Whoops,
Right?
you're right. I left out the square, excuse me. So we have 20 equals 16a, a equals 5 over fourths. So our final equation is y equal 5 fourths x minus 4 squared minus 10.
Mm-hmm.
So you can actually figure out the equation of a quadratic if they give you any 3 points on the quadratic. Notice that if I had any 3 points, and standard format is the following: y equals ax squared plus bx plus c. Well,
Mm-hmm.
if I started with one point, let's say 1 point is 2 comma 4, so I can get one equation by plugging in 2 for x and 4 for y. There's one equation. Notice that I still have 3 variables that I don't know what they are, a, b, and c.
Mm-hmm.
Now they give me another point. Well, I can plug that in and come up with another equation. And I'm going to plug in my third point, come up with a third equation. I'm then going to have 3 equations and 3 unknowns I can solve for a, b, and c.
Yeah.
So all we need is 3 points, and we can come up with it. It's hard because it's not that easy to solve 3 equations and 3 unknowns, but it can be done. Now,
Mm-hmm.
they do have a one down here, it must be on the next page, where they said, oh no, I think it is on this. Yeah, use regression to solve this one right here. Notice they give us 3 points. They don't give us the x-intercepts. They don't give us the vertex. They just give us 3 randomly looking points on the curve. They want us to solve it by regression. Do you have a Inspire CX or do you have the TI-84?
I've got the TI-84.
Do you know how to do a quadratic regression on that?
No. I'll have to, can I run and grab it real quick?
Well, don't yet, because if you're not having to do that, I don't want to go through it.
Oh, okay.
Just because I don't want to spend time on stuff that you haven't gotten to yet. But like a linear regression, if I were to put 3 points in a relatively straight line, well, no, if I were to make 3 points in a straight line, perfect straight line, and I were to give you those 3 points, you could put them into your calculator, do a linear regression, and come up with the equation of that line in y equal mx plus b format.
Yeah.
When you do the linear regression in your calculator, it tells you what m is and it tells you what b is. So you come up with the equation. If you have 3 points and you know it is a quadratic, in other words, I've got a point up here, I got a point down there, and I got a point over there, I can put those 3 points into my calculator, and instead of doing a linear regression, you do a quadratic regression. And it will give me an A, a B, and a C, the coefficients of the quadratic in standard format.
All right.
Okay, which is pretty nifty to do. It's much easier to do it that way on the calculator than it is to try to solve 3 equations and 3 unknowns. Yeah, let me open another page. I came across a problem last night that was really hard. I couldn't believe it. This is it, I think. I've never come across one of these. Well, first of all, have you used substitution? Like, do you know how to solve 32?
Yes.
Okay, solve it for me.
Wouldn't you just pretty much ignore the x to the fourth and make it just a quadratic and say x squared minus 9x plus 8 equals 0?
Yeah, there's some students get taught this and others don't. But there's a technique called using substitution that works really nice. You don't need it for this problem, but you will the next one. So let's just talk about it for a moment. If I let u equal x squared, then I can write this quartic function as a quadratic in u. It would be u squared minus 9u plus 8, which factors easily into u minus 8 times u minus 1. To solve for x, I take my two solutions. My two solutions are u equals 8, u equal 1. I plug them back into the quadratic, start with 8. 8 equals x squared. X equals plus or minus the square root of 8, which is 2 root 2. When I plug in the 1 for u, I get x equal plus or minus 1. Notice I have 4 solutions, and you should generally have the same number of solutions as the degree of the polynomial.
Yeah.
Okay? So let's just look at a more difficult one, but using the same technique. Well, let's see if I can find it. How can I not have this? Well, I tell you what. Let's use the exact one, change that to a 7. Now do it.
Okay, so let's just let u equal x squared.
Okay.
And then it would be u squared minus 9u plus 7. But that doesn't factor.
So how would we solve for u?
Could you complete the square?
Well, we could. But let's use the quadratic formula. We're looking at a pure quadratic here.
Okay.
So u is equal to what?
Negative, or 9 plus or minus the square root of negative 9 squared minus 4 times 1 times 7 all over 2.
Okay. So now, one reason I wanted to show you this, because I haven't seen a problem like this in 5 years of tutoring. So this becomes 9 plus or minus the square root of, what is that, 53 over 2. And u is equal to x squared. So when I solve for x, what is x going to be equal to? And what are the first 2 words out of your mouth should be? Whenever you take the square root of both sides of an equation, the answer is always
plus or minus.
That's what everybody forgets, is that plus or minus. I don't know why. I would say, though, that that's the single biggest mistake all of my students make as a group, more than any other, is they leave off the plus or minus. So now what's the rest of it? What's x equal to plus or minus?
Well, it's 9 plus or minus, right?
Well, no, you got to take the square root of this whole thing.
You do?
Remember, that's equal to u. That was equal to u. And I actually had 2 u solutions. One was plus, the other was minus. Okay? So if we do the first one, we've got 9 plus root 53. Notice the root inside of a root. How often do you see that? So there's one solution, or actually there's two solutions. And the other two, because we need 4 because it's a quartic, is 9 minus root 53 over 2. So that's what x is equal to, those 4 solutions. Now notice that we could not have done this the way you did this one over here. In other words, this one over here, you really, number 32, you really did not need to use u substitution. You had it figured out that it was going to be x squared minus 8 times x squared minus 1. And you could solve it directly that way. But the moment this doesn't factor nicely and you have to resort to the quadratic formula, then you have to use u substitution in order to solve it. And in fact, solving cubics and quartics is one of the most difficult things that you've come up against in math. I don't know how far you've gotten in the higher degree polynomials. Have you gotten to the rational root theorem or the rational factor theorem, the P over Q?
I don't know.
Probably not if you're still on quadratics. That's the next thing you're going to study, is polynomials that are third or fourth degree polynomials.
Well, I studied how to graph those, but...
Well, here's what makes it so difficult, is for quadratics, no matter how hard a quadratic is, we have the quadratic formula that we can use. That will always give you an answer. In other words, you can always find the zeros of a quadratic easily. We don't have a cubic formula, and we don't have a quartic formula. We certainly don't have a fifth degree formula. So finding the roots or the zeros of those kind of functions is amazingly difficult. Surprisingly so. You wouldn't think that it would be that difficult. If I gave you this problem right here, and throw in an x squared term even there. I don't know. Okay, there's a third degree polynomial. That is a 30-minute problem to solve, believe it or not. Make one of these 3 so I can't immediately factor out anything. Okay? That is a 30-minute problem. The answer to this says that the numerator has to be a factor of 12 and the denominator has to be a factor of 4. And there's about 30 different possible things that satisfy that. And you have to try them one at a time to see whether this whole thing is equal to 0. Just plug in. It's trial and error. That's why I say it's a 30-minute problem, because each time you have to use synthetic division to determine whether that might be one of the solutions.
You can't just graph it?
Well, yes, you can. In other words, that's the way we do it. If I stuck that into a graph, I could stick it into Wolfram Alpha on my computer, and it would tell me what the zeros are immediately. But that technology is only in the last 40 years. 50 years ago, you couldn't graph it. There was no such thing to finding the zeros. You had to do it the hard way. And I suspect that they'll definitely have you do that one. Look at 33. It looks kind of interesting. There's another one that I wouldn't be able to do without using substitution. It's a quadratic. What would I let u equal?
2y plus 1 over y.
Now what's the quadratic in u?
U squared equals u plus 6.
Yeah, or if I bring them all over to the same side, now I get u minus 3 times u minus 2 plus 2 So my solutions in U are 3 and negative 2. Now solve for Y.
Would you just plug those both, like 3 and negative 2, into the equation?
Into this equation there. So if I plug in 3, I get 3 equals 2y plus 1 over y, and multiply both sides by y, I get 3y equals 2y plus 1, I get y equals 1. So there's one solution. The other solution I would get if I stuck in minus 2 for that, which gives me minus 2y. Ooh. Whoa.
Isn't it negative 1/4?
Oh, yeah, it is. I was thinking the y's cancel, and I had 0 equal 1, which can't be. Yes, no, you're right. Y equal negative 1/4. I end up with a minus 2y minus another 2y. So that's how you solve problems like this. That would be a brute to solve without the substitution method. Same thing with 34. Notice 34 doesn't look like a quadratic, but it really is. All you need for something to be a quadratic is for the leading term to be the square of the middle term. And y is the square root of y squared. So if I let u equal square root of y, then I got u squared minus 4u minus 5. And I can factor it easily and solve it. No, let's see. Yeah, no, that factors easily. Yeah, I was thinking that was the one that required that real exotic solution. All right. I don't know. Have these been helpful? It seems like this is stuff maybe you haven't gotten to doing yet.
Well, we've done some of it, but the U substitution definitely helps a lot.
Yeah, it does. Like I said, it's very rare that I've actually worked with students that use the U substitution to solve quadratics. This is the first year I think I've gotten 2 or 3 students that have that same thing. Do you know how to find the minimum or maximum value of a parabola?
I kind of. Is that like
About 31. 31 is in vertex format. We know, let's just look at 31 because it's a good one to start with on this.
Wouldn't the minimum just be the vertex, so it would be 1, negative 5?
Well, the minimum they're referring to is the y value. Okay? So you're correct. It's 1, negative 5, and that's what the parabola looks like. Notice that all parabolas either have a minimum or a maximum, depending on whether they're pointed up or pointed down. This one has a minimum, and its minimum value is what?
Negative 5.
Negative 5 is the answer. In other words, we don't care what the x-coordinate is. We just want to know what is the minimum value of this function throughout its domain. And it's minus 5. There's nowhere else that it gets that low.
Would the maximum just be infinity?
Well, no. What they really mean here is that if there's a minimum, tell me what it is, and if there's a maximum, tell me what it is. You're right. That is an absolute minimum, and there is no maximum.
Yes.
There actually is no maximum. You could say it's infinity, but that's a number, and I mean, infinity is not a number, so you can't say that there's a maximum here. So if I was given that quadratic on 29 and wanted to know the min and max, what's the easiest way, the min or max? It looks like it opens up, so they're going to want to know the minimum. It's the easiest way to get it.
Probably just completing the square so you can find the vertex.
That's what I would do. Because I could use minus b over 2a, which gives you the x-coordinate of the vertex immediately. But then you have to take that answer and plug it in to find out what the y value is. So to me, it's easier to complete the square. So if I'm going to complete the square, let's do it one more time just for practice for you.
So you would move the 7 out. And you have 3 times y squared plus 6y plus 9.
Okay, so in other words, this is the same as this. So far I've done nothing to it, just rearranged it. So we're going to add a 9 here. What do I have to do to balance it?
Subtract 27, right?
And so now I can write it as what?
Y, or 3 times y plus 3 squared minus 20.
What's the minimum value in this function?
Negative 20.
Right. Okay, so that's how you do that one. This one here, this is going to have a maximum because of this negative sign. So they want to know what the maximum is there, and we could do a couple of things. We've got to do something to it because this gives us no idea of the vertex. It only is going to tell us the x-intercepts. So we probably need to multiply this together and then complete the square and put it in vertex format. I think probably is the easiest way to go to find the minimum, or rather the maximum. So let's see if we have anything else different here or similar to what you're doing. Problems like 23. Let's just look at it quickly. We have 9x squared minus 14 equals 22. What should I do here?
Bring the 22 over to the other side.
Actually, if you have a quadratic that has an x squared and an x and a constant, that's always what you want to do. Just get everything on one side and 0 on the other. If you have a quadratic that is missing the middle term, like this one is, there's no x term, there's really a better way to solve it. And that is, let's add 14 to the right, divide by 9. What's x equal to?
2. Or plus or minus 2.
I wish there was a song that I could sing that had rhyme to it, so that I could say, whenever you take the square root of both sides of an equation, don't forget the plus and minus. Okay, so that's the way we solve 23. And how about 26? It's similar. I could solve 26 the old-fashioned way, which is to FOIL that. Then I'm going to have an x squared term, I'm going to have an x term, and I'm going to have a constant. In other words, I would expand that, gather everything together on the left side, and then probably try to solve it by factoring it or something. But there's an easier way to solve this also. What is it?
Probably just divide both sides by 5 first, and then square root it.
So what's next line?
And then just it would be x plus 3 equals plus or minus root 7. So then x equals negative 3 plus or minus root 7.
Okay. Wow, when I did this problem last night, I didn't make it root 7. I left off the radical sign so that we came up with two answers, -3 plus 7 and -3 minus 7. So we had 4 and -10 were our two answers. It just occurred to me right now that I forgot to put the radical sign there, which makes two different answers.
Mm-hmm.
All right. 24 is just a straight factoring problem.
Mm-hmm.
25. Can you do 25?
Is that a x cubed?
No, it's this one right here. That's what it is.
So I would let u equal root 2.
Notice they did something here to try to confuse us. Don't be confused by what they did. This is the way it's normally written. Right?
Oh. Mm-hmm.
Now how do you solve this?
I have no idea.
Use the quadratic.
Okay.
It's a quadratic because we got an x squared and an x. It's just our coefficient is a little strange looking, but still going to be able to use the quadratic on it. You can always use the quadratic. So what's x equal to?
X equals root 2 plus or minus 2, or plus or minus root 2 minus 4 times, or just minus 4.
Which turns into a plus 4, right? It's actually minus a negative 4.
Mm-hmm.
Notice, make sure you keep track of your negative signs here. It's b squared minus 4 times a times c. So it becomes 2 plus 4, or 6.
All over 2.
And that's your answer, actually.
Mm-hmm.
Simplified. I guess, does he want all of your answers in a plus bi format? In other words, I could switch this into two fractions, and when you work with complex numbers more, you'll know that the standard format for a complex number is a plus bi. So this answer, this is not a complex number, but it's a irrational number. So I can imagine that somebody might want to see it like this.
I think it's fine with just
yeah, it probably is. If it's an imaginary solution, then I think it's very important to put it in this form, because a plus bi is such a standard format. In other words, if I had an I there, I would want to do it in this way right here, because this is the real part and this is the imaginary part.
Yeah.
Okay. Well, I hope we covered the stuff you're studying, but
Yeah,
I couldn't resist, because these were some pretty interesting quadratic problems.
Mm-hmm. It helped a lot.
Good. Griffin, have a nice Thanksgiving if I don't talk to you before then. And
right,
yeah, you're probably off all next week, aren't you?
Mm-hmm.
Okay. Have a good one.
All right, you too.
Bye-bye.
Bye.